Hello and welcome back to California Geology. Today I want to talk about gold in the Sierra Nevada. Now, gold in California was discovered actually more towards the end of in the early 1800s down in Southern California. In fact, there's a locality down in San Isidro where it was located. But really, it became famous and the news really got out to the rest of the world in 1849. After the discovery of gold by James Marshall. So he actually discovered gold on January 24th of 1848 on the American River, where he was working a sawmill, and he was having some problems. We had to dig out a ditch deeper, and he actually did some blasting, and he went out to see if the channel was deep enough. He noticed these, he called them blossoms, and he picked up the metal and tested it, and it seemed to be malleable. It was an unusual color, and he took it down to Sutter's Fort, and Sutter tested it there, and they realized that they did have gold. And what was unusual about this gold is that it was nearly, well, in fact, what it was pure gold, basically 24 karat gold. And so this kind of spawned the gold rush, where people started coming, trying to find their fortune. And by the end of 1848, there were 20,000 non-native people in California. And then 5,000 of those were miners. By the end of 1849, the population jumped to 100,000 non-native Californians. And then by the end of 1852, the population was 224,000 non-native Californians, and literally about half of those were miners. And the gold rush really started in the late 1848 once the word got out. Mostly Hawaiians and people from Mexico and South America came over. But throughout 1849, people from the eastern United States, as well as from Europe and other places of the world, really started coming into California. And it really ended in about 1852, so it was sort of short-lived. Only because the easy stuff, the placer deposits, were pretty much exhausted. And remember, the placer mining we'll talk about is the gold panning, finding the gold nuggets in the riverbeds, on the beaches. That's the easy stuff. It's pretty inexpensive. Pretty much anyone can set up their own mining company. You get some boards, some various rockers, sleuth boxes. You can look for gold. But once those were used up or discovered, the other type of mining is kind of hard, and that's the hard rock mining, which involves going underground and following the quartz veins. So the unusual thing about the Sierra gold was it's native gold. What that means is gold is not mixed with any other metals. There's other minerals where gold and silver mix, so the quality of gold isn't very good when it's mixed with other metals. But here this gold is native. And usually gold likes to be by itself, so it doesn't mix with any other types of minerals or chemical elements, so it remains by itself. And then also that makes it not weather very well. So it does not weather, and it lasts, and it survives erosional and weathering systems. And it might break down in flakes, so that's why a lot of it is in small flakes. Now, one note that Hardin makes in your book is that most Sierra gold is about 1/4 to 1/2 ounce per ton of ore. So ore, which is spelled O-R-E, is really anything that's profitable to mine. If you can make money off of it, it's called ore. And so the gold ore was primarily in these quartz veins, and then so the gold is mixed with these quartz veins. The veins were anywhere from 3 meters to 30 meters thick. And so that's this lode deposit, the hard rock mining, where you have to go underground, follow the vein, and it marks this region called the Mother Lode District. And the Mother Lode really goes from Mariposa over here all the way up here into about the Yuba River, right? So that's really the Mother Lode, and it follows this 195-kilometer long stretch of the Maloney's Fault Zone. And it's closely tied to the accreted terrains, those terrains of island arc rocks. Remember the Northern Sierra terrain, the Shoe Fly complex, the Calaveras complex, the Sonoma terrain, foothills terrain. All those were materials that brought the gold to California, and they primarily formed in oceanic settings. Remember the oceanic setting, there are mid-oceanic ridges with black smokers, hydrothermal vents, and they're really concentrating all that minerals, gold, silver, copper, at these mid-oceanic ridges, but later on that's being attached or accreted to California. And one of the problems is it was really disseminated during those orogenies, Antler orogeny, Sonoma orogeny, Nevadan orogeny. But later on, the granites of the Sierra Nevada, the batholiths, is gonna do something to concentrate these materials. All right, so the two types of deposits we find in the Sierra are the low deposits, which are the hard rock mining ones, and then these placer deposits, which is the stuff you do panning. You need a sleuth box. Those are the gold-bearing gravels, right? So some of the hydraulic mining was also done in the placer deposits here. Now, looking at the lode mining here, by basically 1852, pretty much all the placer deposits were discovered and used up. People realized that they had to go underground. And one of the problems with lode mining is that it's expensive, it's dangerous, you're going underground, people would need to form basically corporations and sell stock on the stock market so they can buy these equipments so that they can go underground and start drilling for the gold here. So again, the gold in these lode districts are the quartz veins, and they're mostly in the metamorphic rocks of these accreted terrains, Sonoma terrain primarily, and the Northern Sierra terrain, occurring along that Maloney's fault zone. And some of the veins also occurred in the granitic rocks. For example, in the Grass Valley district, there's an Empire mine where the quartz veins are in a granodiorite. Now, here's a picture of some miners going down to do work in the mines, and again, it's dangerous. And let's see, in 1922, there's a mine in the Sierra Nevada called the Argonaut mine, and there was an accident where the problem with working underground is poor ventilation, and in order to support the mines, you use these timbers to hold up the roof. And so there was a fire down there where the timbers burned, and the fire occurred in an area above where the miners were working, and basically 47 miners died in that accident. So again, very dangerous working underground. So once you extracted the ore from the hard rock, from the mine, you would have to bring it to the surface, and then now the problem is you have gold mixed with the quartz ore, right? So you have to kind of break it up, and they designed this thing called a stamp mill, and the stamp mill has a variety of stamps, each one weighing anywhere from 5 to 25 pounds. And what happens is they were on a camshaft here, sort of this camshaft. As you spin it, the different stamps go up and down at different times, up and down, and the quartz ore is trickled through here, and this thing crushes it into finer material. And then once you crush it down, then the crushed rock is processed like placer deposits. You roll it down a sleuth box, and I'll show you one of those in a moment. Or there's these long toms, these rockers, variety of tools that you can use to separate gold from sandy sediment, silicate minerals. One of the key properties of gold is that it's heavy. It has a very high specific gravity. The specific gravity of gold is about 19. In other words, it's 19 times heavier than water. Quartz, feldspar, the specific gravity is about 2.7. So you can see gold is much more heavier. So it sticks to the bottom of pans. That's why gold is often found in potholes, in riverbeds. It's deep down there because it settles to the bottom. Now, the other type of mining is this placer mining. In fact, here's an image showing some miners working a placer deposit. You can do some panning here, or load up your buckets with material from the river bottom, hopefully a pothole, and then you put it in this rocker where you would rock this back and forth, and with water running through there, and the lighter quartz and feldspar and other materials will flow at the end, but the gold, since it's heavy, it's going to stick to the bottom here. And so primarily gold dust, gold flakes is what you're looking for here. And here's another image of some panning going on here. And then this is actually called a long tom. So the long tom is similar to the sleuth box, where you're allowing water to run through here. And then this long tom usually has some little rails that go perpendicular, so it'll catch some of this the finer material, the gold that'll stick to the bottom of this trough here. So here's some miners working the long tom. In fact, here's a modern long tom. Here's the little slants that kind of you'll put the material in here. You'll wash away primarily the sand and silt that you don't want, the silicate minerals, and in the bottom here the quartz will stick, and that's what you want to collect later on. Now, some of the properties of gold. Remember, gold is soft. It's malleable. That's one of the key things that I always say is in the pirate movies. If you a piece of gold given to the pirate, the first thing the pirate will do will bite on it because it should be soft. Gold has a very high specific gravity, 19. It has a distinct yellow color instead of a brass color like the fool's gold, the pyrite here. So in terms of pyrite, pyrite has a lower specific gravity of 5. So in other words, it's 5 times heavier than water, equal amount of water. Brass yellow instead of yellow. And it also forms these cubic crystals, sometimes with striations on them here. And when it breaks in a conchoidal fracture, kind of a curvy fracture here, right? So it's going to be different than gold. Gold will really bend and be malleable. So here's a quartz vein with some nice gold in there. All right, so the origin of the gold, remember, it occurred in the decreted terrains when they were attached to North America, to California here. And remember, the gold is concentrated at these hydrothermal vent systems where the black smokers occur. And then when in the decreted terrains, it was disseminated. But then once Franciscan subduction started and you started forming the batholith, the Sierra Nevada batholith, the fluids that came out of the batholith, usually in fact, the lowest temperature mineral to form, the last mineral to form in magmas is quartz. And so quartz fluid veins are shooting out of these magma chambers into the country rock. And the country rock in this case is a metamorphic rock of the foothills belt here. And so when those quartz veins shot through these foothills terrains, they picked up that disseminated gold ore and concentrated them in these quartz veins, right? So gold-bearing veins cut across Mesozoic, metamorphic rocks, and even some of the granitic rocks, right? Like in the Grass Valley district there. And so based on the ages of those metamorphic rocks and some of those plutonic rocks that are cut by these gold-bearing veins, geologists have estimated that the emplacement of the gold was between 115 to 120 million years ago. Now, how do you separate the gold from the quartz? Another way to do it, the stamp mill, but there might be still some attached. Well, one thing you can make an amalgam. An amalgam is a mixture of two metals. In this case, you would take the gold ore that has quartz in it and add mercury to it. The mercury will attach to the gold, and then you would heat that amalgam to vaporize the mercury away, and it leaves pure gold behind. Another method is that you can actually use cyanide, and cyanide dissolves the gold in the quartz as well. And the use of cyanide actually increased the efficiency of getting the gold out by 100 times, right? So a variety of ways, but both mercury and cyanide obviously are not really good for the environment. One of the connections we'll make later on with the Sierra Nevada gold deposits and the Coast Range's mercury deposits, right? So the quicksilver deposits here, like in New Almaden mine, those are all cinnabar, and the cinnabar is a mercury mineral, and so the mercury really came from the Coast Ranges so that we can extract the gold from the Sierra Nevada. So there's a connection there.